So then we talked about the first stage of deep learning. We talked about why machine learning is important. We talked about why layers are important. One of your exercises today will actually showcase that exactly. You'll see how a linear method fails you. And we talked about the first sort of neural language model, very costly, into the details, and then we talked about the advantages of recurrent neural networks. Okay, that's the first part. The second part of the first stage of deep learning, we talked about further about RNNs, this architecture, how it evolved to tackle long distance dependency problem, also vanishing and exploding gradients. We talked about representation learning and autoencoding, and then we talked about how it transferred into an encoding decoding architecture, which is most of what you do these days, including the summarizer. If you're working on the summarizer, you have to do an encoding decoding architecture because you're generating. If you're doing text classification, you don't need the generator, and generation is not easy. Okay. So we talked about now the shallower methods and easier methods for your computer, so computationally inexpensive methods to get a word representation. And we talked about a better method. Both of these methods are very common these days. A glove. You can ask me anything about the details of it. The point of right now is just a quick recap. Okay.
So there is one question from online which is related to NLP, so I thought it's better to ask it now. Eric is actually asking for NLTK, what is the concept of context? Is it like only surrounding words of a specific word, or?
Yeah. So we talked about context in two different manners in the videos. One was NLTK, and I think that's what he means, and we define it as just the word surrounding your target word. The word in mind, and then we have context in the programming sense. That's some of the keywords have context associated with them, scope associated with them, such as the with open sort of keyword set.
So in let's say you're talking about the language, is it like it's the basic idea of the context, which is like we'll look at these surrounding words and then get an idea of what the context of the specific word is.
Exactly, yes, because otherwise you don't know which sense of the word we're talking about. Usually with context, it can be disambiguous. So if you pick a task called word sense disambiguation, disambiguate the sense of a word, and you can do that with your context, with the context where the word occurred in. And you can use various methods. All right, thanks for the question. So anyhow, so then we talked about a second remedy to the long distance dependency problem and vanishing exploding gradients. Mostly a long distance dependency actually, which is attention. So hopefully by now you know quite a few attention mechanisms. So this is the original attention that was used for machine translation. And you can see how you can visualize it. So a lot of the time, so there is a myth and then there is some reality. The myth is that deep learning is not explainable. That's not correct. Like you can actually explain things with deep learning that you cannot otherwise. So if we're talking about images, deep learning has the power to show you what component exactly is the machine paying attention to when making a decision. Is it looking at your face? Is it looking at your nose? Is it looking at how tall you are? And if you're using unstructured data such as images, it's very hard to do so with non-deep learning methods. By doing so, I mean explaining why your machine is making a decision. So for unstructured, so it's not that deep learning is not explainable, it's that unstructured data is very, very hard to explain. So text is very, very hard to explain. Images are very hard to explain. If you ask humans, they got to think about it as well, right? it's multivariable. So it's also it doesn't know. Anyhow, so there are work being done in explainability as well. But the reality is it's hard, and as you see here for the attention mechanism, you see that sometimes it does really make sense. It makes sense for I don't know, is to look at FBI, to perhaps guess the count. But sometimes it's harder to interpret. Anyhow, don't get it as a gospel, but
when I saw this video, when I watched this video, I had the question if there's a difference between languages regarding attention mechanism. Because I believe there's different structures of languages, and so some of them, especially in English, it's very important where there's a verb, where is the
correct.
And in Russian language, we could mix them up.
That's correct.
So, if there is a difference with the approach for different languages, or the same approach but the different results.
Correct. So with the same approach, you can get different results if you're using different languages. Because with deep learning, you start from almost a clean slate, and then you train it how you train it. It's like having a baby born in to a Russian family. They definitely will learn Russian if they're healthy. And if they're born to an English family, no matter what their race is, they're going to learn English, right? So yes. So if it's say it's Russian, in Russian you still have agreement, right? And that's why you can move things around because verbs agree with subjects, right? If you switch them, you will still pay attention. Your attention would still tell you what it's looking at for a different reason. But agreement is almost a general case in all languages because you talked about an entity, you want to refer to it.
Especially in German when the verb is the end. So in this example, we're always looking backward, but when we reading German sentence, we need to go to the end.
Great question. So this is about
do you mind summarizing each of the questions as well as you can?
Of course. So the question is, this is only looking backward. In other languages, you may want to look into the future. In English as well, it doesn't hurt to look in the future. The reason you're looking backwards is because it's intra-attention. In intra-attention, you only look backward because the next word you haven't generated yet, right? Technically. Yeah, good question. Okay, but in general, you look everywhere. And we talked about soft attention, global versus local and hybrid attention. I don't get to the details. Basically, the most important ones, if you ask me, are inter and intra-attention. And that's because you want to keep the sequence. Okay, so that's how far theoretically we went. Now let's talk about the last part of but let me pause a little bit and ask you if you have any questions so far. So far, all we talked about, you already watched the videos hopefully, or to some extent the videos. Let's ask any questions you might have. Then I'll go through the last attention type, which enables you for almost anything these days to do at workplace, any type of architecture in NLP, deep architecture in NLP. And after that, we have a little bit of question period, and then go to the a few exercises to teach you things that you haven't seen yet. So questions here in the class?
I'll like people if you have questions now.
Yeah.
So for the case of like NLP Agile development, do you like set sort of like benchmarks or metrics per per sprint or whatever like that, and then what's your release cycles like to engineering, and then how do you get that feedback? Like when do you get that feedback?
Amazing question. So one, you may spend an entire sprint just to figure out a metric in machine learning, especially NLP, because it can get really hard. Like if you want to explain something, it's to a business, let's say finance or law, it's very hard to do that. So you gotta come and sometimes we train, and that's why summarizer is a hard task. For example, like we don't actually know what's the best summary. Like we can qualitatively say I like this summary, but and if you're an expert, probably if you're a linguist, probably you can pick up on a few things to say, but not everything. Even a human expert cannot tell you, cannot verbalize why they like a certain summary better in every possible detail, right? So you may have a sprint only focus, and the metric is the first part. You no matter what you do, what you're doing, before even solutioning anything, you gotta have a metric. So always, and so I go into a lot of meetings and people talk about solutions. I'm like, what solution for what? You don't have a metric, you don't have a problem to solve. Period. So come with a metric. Come with a metric that actually reflects your goals. If you can get and you don't have to always be able to convey that exactly to the business people, but you have to definitely digest what they care about if it's an interaction. Okay, so with the cycle, you can select what your product is for each sprint. It doesn't have to be a model. It definitely shouldn't be a model from the get-go. At first, you need a metric, then you need a baseline. And think about it as the most idiotic, simple baseline, because you got to beat that first, right? And something that's so a baseline is something that you can generate as soon as possible. Maybe that's good enough. You do this 50%. You bring the workload down of a poor person sitting at a computer by 50%. That's a lot. If you don't have that, and if you give that, your engineering team is unblocked. They can go and deploy it. Next cycle, you can give them something better, right?
So how do you establish that baseline?
So to be able to sort of devise a baseline, you got to know an end-to-end sort of understanding of NLP. The time of workshop is limited, so I can't tell you every detail in every part of this entire pipeline. But as I say, NLP is very, very vast. But when you have an understanding of characters, of words, of how a frequency, for example, can be a simple measure, an understanding of text, and then all the way, then you can come up with the baseline. So the other thing about the baseline is that you can't just come up all the time with baselines. You got to have a vision as to how you're going to improve it. So you know where to end. So we know as a fact that deep learning just outperforms everything else out there. Right, so you know that's where you want to get. Now, whether or not you practically get there is a question you got to ask yourself. Like, do I need to get there? If you need to get there, get there. So we're talking engineering, right? We're not talking science. If we're talking science, then you would still need a baseline. It's impossible to talk science in the baseline, but you definitely get where you want to get with science, because your goal is not to deliver a product, is to improve a present solution for public benefit, right? So you always will get to the deep learning and push the cutting edge. In engineering, you don't have to push the cutting edge. A lot of times, sometimes you will actually. Like in my experience, it's 50-50. At least 50% of the time that I work on a solution, and there is novelty involved, and I can go patent it, and more often I do. So you can go. You can see it's very interesting. Anyhow, did I answer your question?
Yeah. So you're going. So the metric, then the baseline.
That's it.
And then you're iterating on the model.
Yes, but what the deliverable is it's really dependent on your problem. Because if the problem is harder, you got to break it down, and your sprint could be just a sub problem, right? It's a really good practice to sit down and plan a few sprints ahead, for and let the engineering team level the expectations. I say this is what it is. This is how it's going to take, roughly. Again, and also make sure they understand what a stochastic process is as opposed to a deterministic process.
And then for data exploration, like how do you put that into sprints?
Oh, that's absolutely. That's like you have to have an understanding of the data. So an entire sprint could be data exploration, depending on how big the data or how messy the data is. With Deliver works that 80% of it wasn't data not exploration, but data culinary exercise. I'm sure you've all had that. Yeah. So that definitely is a very legit sprint everywhere. If an entire sprint is, if you can parallelize, definitely parallelize within your team. But it's good to be able to focus. So don't give. I notice that when you give people like more than one task, per sprint, they take longer than you would imagine. Like it's not really 50-50 because the context switch. Okay, all right. Any other questions from people here or online?
Can you hear me?
I can, yes.
I have a question actually related to particularly NLP development.
Yep.
What are the common ways to tackle small data that is available, like small clients data, textual data, which is probably not labeled or partially labeled, but the main bottleneck is that there's not enough data to train a decent model on. So what's the common ways to tackle this problem? Is it, I don't know, traditional transfer learning or active learning? So basically, I'm interested how this problem is tackled in NLP.
Okay. So by this point, I assume that you know that you shouldn't start from. So you can use you can start with your baseline that could be definitely unsupervised, right? But when you get to this, when you want to improve and you want to use a supervised algorithm, and you face lack of data, then again, try to use an unsupervised machine learning algorithm first. But when you absolutely have to use a supervised algorithm, because it takes longer, right? When you don't have data, it just takes longer. Yes, active learning is a solution, so you can deploy and get feedback from your audience. That's actually an amazing solution. That's why nobody can beat Google in search anymore, because they just have a customer base that they can learn, and the more they use it, the better the algorithm gets. So that's one way, but it's engineering wise, it's costly because you have to deploy a UI, and you got to make sure your UI talks back all the way to your model. So it's a big, you get your pipeline is bigger, so it's a little bit risky. If you can have independent modules in your pipeline, it's better. But it's amazing. It's just that it's an engineering effort. You can use data augmentation practices. There are various ways to depending on what the task is. What did you say the task was?
Well, normally, let's say for classification, it's well, I know how to augment it, like change words between words, right? Or I don't know, put synonyms of different words.
Yep.
Let's say if you have a task such as, I don't know, text summarization or named entity recognition, how to deal with it.
Yeah. So for text.
And another question is, what are the common unsupervised methods for small data? Let's say for text summarization, named entity recognition.
Okay. So let me tackle your first question first. So your for text summarization, for each task there are ways you can augment your data and have a bunch of data. Text summarization is actually easy because you can find any news source online, and your headline will be your summary, right? And news is just doesn't end. It may bias these days your performance into, I don't know, coronavirus, for example, but anyhow, news is very general. And so that's for text summarization. And the other question was, how do you do this for NER, or what was the question? Second?
Yeah, the second question was, you told before that if you don't have enough data, start using unsupervised methods first. So I'm just wondering what are these methods? Maybe
nice.
There are some specific methods.
Right, nice. And you can ask me more. So the things that I didn't get to too much detail, just to keep things manageable. But for example, for name entities, for persons, you know that if there is like in English, if there is a person name, its initial letter is capital S, right? So you can use that, and then you can filter out things that occur at the beginning of a sentence because they're going to be capitalized anyways. So you can definitely use rule-based methods as a starter, and then move on. With unsupervised methods, usually the common solution these days is to get a representation, and representation is it's technically unsupervised. If you remember the autoencoder, it's technically unsupervised, but you have some sort of supervision, and your supervision is your sorry.
Can someone online mute themselves?
So you usually get to a representation. Usually nowadays you can use neural language models, just generating the next word, so that's your signal, or encoding and then decoding, that's and then getting representation. Usually you get a representation, and you use some sort of distance method to see how far things are. So that's another very common unsupervised method that's used. Yeah. For if you have specific,
Young, it's you. You need to mute yourself.
Okay.
Or something. Somehow you became the host. There was a transfer.
Okay.
okay, so I think you got the answer at this briefly. If you have, and we'll open it up again if you have more questions. Definitely do ask. Okay, any other questions from online or? Yeah.
Okay, regarding text summarization, is it bidirectional? So if we could summarize, so we could to go back and make from the short line, from tagline, make it more text with the same model. I mean, the same model trained on the same data.
So when you say bidirectional,
I mean, if we could
Okay, I'm working on it.
from the big text, we could make a summary. So we could make from the summary the.
well, yeah, but that's text generation. That's not summarization anymore. But you can do that, yes.
And with the same model, we could rebuild completely.
With the same model, no, because your same model, you can find a smart way probably to reverse engineer your weights. But the same model is trained to output a smaller sequence, even a larger sequence. Okay, I want to prioritize people who haven't asked questions. If you haven't asked questions, you can ask in the next couple of minutes. If there are no questions, we're going to move on. I'm not even joined on the audio.
Oh, okay.
Yeah. All right. Let me full screen this guy.